Hey there, welcome to my channel. In this video, we're going to talk about unearthing ancient eruptions, decoding past VEI ratings. But before we get into all that, make sure you hit that subscribe button down below so you never miss an exciting episode. Volcanic eruptions have shaped our planet's history and continue to be a source of both fascination and fear. These awe-inspiring natural events can cause massive destruction, but they also play a crucial role in shaping our planet's geology and climate. The Volcanic Explosivity Index, or VEI, is a scale used to classify volcanic eruptions based on their severity. It considers factors such as the volume of material ejected, the eruption column height, and the explosivity of the eruption. However, this index is primarily designed for recent historical eruptions. Assigning a VEI rating to ancient eruptions that occurred thousands of years ago poses unique challenges. Join us as we unravel the complexities of determining the VEI of ancient eruptions, highlighting the difficulties and innovative methods employed by scientists to piece together these explosive events from the distant past. Now let's dive into the fascinating world of ancient eruptions and explore how scientists are working to unlock their secrets. The task of determining the VEI of ancient eruptions is fraught with challenges. Unlike recent eruptions which have detailed records and physical evidence, ancient eruptions leave behind only fragmented clues. Scientists must rely on various geological and historical records to reconstruct these eruptions and assign them a VEI rating. One approach involves studying the physical characteristics of ancient eruption sites, such as the volume of material ejected and the height of the eruption column. By analyzing these indicators, scientists can estimate the explosivity of the eruption and assign it a corresponding VEI rating. However, obtaining accurate measurements of these parameters in ancient eruptions can be challenging due to erosion, post-eruption modifications to the landscape, and the absence of complete records. Another approach involves examining the composition of the erupted material, including the type of volcanic ash and the presence of tephra layers. By studying the composition and distribution of these materials, scientists can gain insights into the eruption dynamics and potential VEI rating. However, this method relies on the preservation of these materials and the ability to correlate them with specific eruptions. Additionally, paleontology, the study of ancient human settlements and artifacts, provides valuable information about past eruptions. By examining historical accounts, artwork, and oral traditions, scientists can piece together the impact of ancient eruptions on human civilizations and estimate their magnitude. However, these sources may be incomplete or biased, making it challenging to reconstruct the full scope of the eruptions. Scientists employ various techniques to determine the age and chronology of ancient eruptions. Radiocarbon dating is commonly used to establish the age of organic materials found at eruption sites. This method helps establish a timeline for the eruption and its associated events. Additionally, scientists utilize luminescence dating, which measures the accumulation of light in certain minerals, providing insights into the timing of the eruption. By combining these dating techniques with historical records and geological evidence, scientists strive to accurately determine the age and sequence of ancient eruptions. Let's take a closer look at some of the challenges involved in deciphering the VEI of ancient eruptions. First, the limited physical evidence. Over the course of several thousand years, many ancient eruption sites have been subject to significant erosion, altering the surrounding landscapes. This erosion has made it difficult to identify the true extent of the eruptions. Second, the difficulty in accurately dating ancient eruptions. Without precise dating methods, it's challenging to determine when these eruptions occurred, which makes it hard to correlate them with historical records. Third, the absence of comprehensive historical documentation. Many ancient cultures did not keep detailed written records of volcanic events, leaving us with fragmented accounts or relying on oral traditions that may have been lost or distorted over time. Fourth, the subjective interpretation of available evidence. Much of the evidence used to infer the VEI of ancient eruptions is open to interpretation. Scientists must carefully evaluate each piece of evidence and make subjective judgments, which can lead to different conclusions. Fifth, the complexity of eruption dynamics. Volcanic eruptions are highly complex events influenced by various factors such as magma composition, eruption style, and external conditions. Understanding these dynamics is crucial for accurate VEI determination, but it can be challenging due to the lack of data. Now that we've covered some of the challenges, let's discuss some innovative approaches and recent advancements in the field. Recent studies have employed interdisciplinary approaches integrating geology, archaeology, history, and geochemistry. By combining various perspectives and data sets, researchers aim to develop more accurate and comprehensive VEI ratings for ancient eruptions. For example, the VEI of Mount Vesuvius's eruption in 79 AD, which buried the Roman city of Pompeii, has been the subject of ongoing debate. Recent studies have re-evaluated the available evidence, including historical accounts, archaeological findings, and geological data to propose a revised VEI rating. Similarly, the VEI of the 1815 eruption of Mount Tambora in Indonesia, the largest eruption of the past 10,000 years, has also been the subject of research. Scientists have revisited historical records and conducted geophysical studies to refine the eruption magnitude and its global impact. These studies highlight the dynamic nature of scientific inquiry and the continuous efforts to improve our understanding of past eruptions. As we continue to explore the VEI of ancient eruptions, it's essential to recognize the complexity and uncertainty inherent in this endeavor. While scientists strive for accuracy, the fragmentary nature of the evidence and the limitations of current methods introduce challenges. Nevertheless, through interdisciplinary collaboration, innovative techniques, and ongoing research, we can enhance our ability to decipher the magnitude and impact of these ancient events. It's important to note that assigning a VEI rating to ancient eruptions is not just an academic exercise. Understanding the severity of past eruptions helps scientists assess volcanic hazards, predict future eruption behavior, and develop effective mitigation strategies. Moreover, it provides valuable insights into the evolution of volcanic systems and their long-term impacts on the Earth system. One way scientists are improving the accuracy of VEI ratings is by utilizing advanced remote sensing techniques such as high-resolution satellite imagery and aerial photography. These methods allow for detailed mapping of eruption deposits, providing valuable information about eruption extent and volume. For instance, satellite-based synthetic aperture radar, SR, can penetrate forest cover and map buried tephra layers, helping to identify areas affected by ancient eruptions. Another approach involves the use of ground-based geophysical methods, such as magnetic and electric surveys. These techniques can detect subsurface features related to ancient eruptions, providing insights into the eruption's size and depth. By combining these modern techniques with traditional geological methods, scientists are able to obtain a more comprehensive understanding of ancient eruptions and improve their VEI ratings. Furthermore, scientists are increasingly incorporating high-resolution bathymetric data into their investigations. Bathymetric data provides detailed maps of the sea floor, allowing researchers to study submarine eruption deposits and assess their volume. This is particularly important for understanding eruptions that occurred in marine environments where traditional geological methods are limited. Advanced statistical and modeling approaches are also being employed to analyze existing data and improve VEI estimates. By applying statistical models and numerical simulations, scientists can better understand the relationships between eruption characteristics and resulting deposits, leading to more accurate VEI ratings. As technology continues to advance, we can expect even more sophisticated methods to be developed, further enhancing our ability to investigate ancient eruptions.